This is a classic chemical reaction that can be used to get people interested in chemistry. As you go from adding pretty common lackluster ingredients, and all of a sudden you get a big puffy cloud erupting out of nowhere. In this presentation, however, we are going to dive in about what exactly is happening from a chemistry standpoint to produce a visual reaction that we see. Quite simply, the only chemical reaction occurring here is the decomposition of hydrogen peroxide. As you can see from the chemical equation here, two molecules of hydrogen peroxide decompose to produce two water molecules and a molecule of a molecular oxygen or oxygen gas. It is the oxygen production that is important in producing the visuals of the quote-unquote elephant toothpaste. But it wouldn't happen unless we have the other ingredients in there as well. The other ingredients that are necessary for the creation of the elephant toothpaste are yeast and soap. The video from the module says to add food coloring, but is not necessary for the main reaction to take place. I found out that instead of yeast, you could potentially use potassium iodide, as the iodide is actually a catalyst for the decomposition of hydrogen peroxide. Instead of iodide, I'm going to use baker's yeast because it turns out that the yeast, being a biological organism, has an enzyme in it called catalase that provides the same function as the iodine would, which is to catalyze and the decomposition of the hydrogen peroxide into water and oxygen gas. The enzyme works at such a fast rate that the oxygen gas is very quickly produced, and the soap that is dissolved in the reaction mixture is used to essentially encapsulate the oxygen that is being formed which causes the quote-unquote elephant toothpaste to grow out of control. The results of my reaction were as predicted by the video. I didn't use food coloring, so I didn't get the neat looking pattern of colors on the elephant toothpaste, but it did bubble up very quickly and rapidly. I first added the yeast to the warm water in 1 cup, while adding 3% hydrogen peroxide and dish soap into another cup. Once the yeast was mixed up into a slurry enough for me to pour, I added it to the cup containing my hydrogen peroxide and dish soap, and it immediately began reacting. Unlike most of my other experiments, this one turned out to be a success. I now understand and agree that this is a good reaction to show beginners or to entice wonder in someone that may not know much about chemistry or about what they may want to study. Just seeing a reaction like this makes me wonder what is going on for this to happen. And with this project, I was able to find out exactly why. The only difference between my experiment and the one in the video was I couldn't find any 10% hydrogen peroxide, so I was left to only use 3%. This resulted in a reaction not producing as much volume of oxygen gas and therefore not as much elephant toothpaste. If I had used 10% or perhaps even a greater volume of hydrogen peroxide, I would have more of the toothpaste produced. But overall, I enjoyed this experiment and it was very informative.